In my last video, I looked at solving equations with at least one absolute value. In this particular video, we'll look at solving inequalities with one absolute value. Now here's a definition we went over in the last video. Absolute x, or the absolute value of x, is equal to x if x is greater than or equal to 0. Absolute value of x is equal to minus x if x is less than 0. So again, the definition is basically telling you that the absolute value of any quantity is either going to be positive or 0, but never negative. Okay. So again, you have the absolute value of 2 will equal to 2. If the quantity in the absolute value bars is negative, for example, the absolute value is negative 2, you take the opposite of negative 2, you get a positive. Okay. And of course, the absolute value of 0 will be 0. Okay, so I'm going to look at some very basic examples. As suppose we have the absolute value of x less than or equal to 7. So we want to solve what values of x will satisfy this absolute value inequality. And we use the basic premise that we know here. We know the absolute value of a negative 7 is 7, and we know the absolute value of a positive 7 is 7. So we start with that on this number line. And you can see that if I pick a number larger than 7 and put it into this inequality, say 7.1 or 8, the absolute value of that is going to be a positive number, and it's going to be greater than 7. So that's not going to work. If I go over here on the left side of negative 7, say pick a negative 8, absolute value of negative 8 is 8. That's going to be greater than 7, so that's not going to satisfy it. If I pick a number in between, say 1 or negative 1, I'll get a result that'll satisfy this inequality. So my solution set then will be everything in between. Notice the absolute value of negative 7 is 7, so this is less than or equal. So the 7 is included. So here I would put a little dot filled in. And basically, I would take everything in between. That's your solution. Okay. I can also say then that x has to be less than or equal to 7, but greater than or equal to a negative 7. And that would satisfy. Okay. Now, I want you to realize that this is actually one solution here. Okay. And this can also be written as x less than or equal to 7 and x greater than or equal to a negative 7. Okay, those represent the same thing, just different ways of writing the same solution. Okay, the and here implies intersection, so we're taking all numbers less than or equal to 7 with all numbers greater than or equal to negative 7. That of course gives everything in between, including the negative 7 and the 7. Okay, so this is one way to express your solution. This is another. The one that's more popular is the one in interval notation. So I'm going to write it this way. This is interval notation, brackets, negative 7, and then a 7, and then another brackets. Okay, so you have a number line representation for your solution here. You have this format here. Okay, using the symbolic form. Okay, and then this is rewritten with the and implied intersection, and you have the interval notation. This one right here is the one I usually recommend. You write whatever your instructor suggests to you. The one that I usually wanted my students to give me was the interval notation. solution in interval notation. Now, I want to point out to you that if you're solving absolute value of x less than 7, strictly less than 7, doesn't have the equals, and the only thing is that these endpoints here would be open. Okay, so it'd be open circle here, or sometimes you'll see parentheses like this, okay, indicating the -7 and the 7 are not part of the solution, or instead of that, if it's equals, then they'll put the little brackets here. Okay, different ways to give you solution depending on what textbook you're using or what your instructor recommends. And over here, again, the only difference is if this was less than, I wouldn't have the equals right here. It would just be x greater than -7, less than 7, and this would be x less than 7 and x greater than -7. And here in the interval notation, if it's strictly less than, instead of the brackets, you have the parentheses like this, okay? Then you have the -7 and the 7, okay? Different ways to write your solution. Okay, let's clear this. Now, suppose we go the other way. Suppose we have absolute value of x greater than or equal to 7. Okay, again, I'll start off with, by putting -7 here and 7 here. So now we want numbers that satisfy this inequality. So now you can see the numbers in between -7 and 7 are not going to work because absolute value of those numbers are going to be less than 7, not greater. So in this case, I got to go larger or equal to 7. So I shade it in here, or I put a parentheses, either way you want to do that, and take everything this way. Shade it over here, everything this way. Okay. I can also put brackets here. If it doesn't have the equals, if it has the equals, I would put brackets. Okay. So then this would be, using the symbolic form, x then has to be greater or equal to 7. And in this case, I have to use the word or. Or x can be less than or equal to -7. Okay, so this is one solution, and you have your number line representation here. And like I said, in this case, I could also have brackets here and a bracket here instead of the shaded circle there. Okay, in interval notation, keep in mind that -infinity is over here, the left side of this number line. Positive infinity is on the right side. So in interval notation, this would go from -infinity to -7. And then again, you never put brackets on the -infinity or the positive infinity, only on the number if it has an equal. So in this case it does, so I put a bracket here. The or implies union. Okay, so this would be a U here. Okay, so this is union 7 to infinity. And that's the way you would express your solution. So several ways. I could also use set builder notation, but these are the main ones. Okay, so you got this form here, the interval notation here, we got your number line over here, and there you have it. So again, when you're working with these, the or implies union, the and implies intersection. So again, I can't have a number greater than or equal to 7 and at the same time less than or equal to -7, so I have to use the or. That's a union. Okay, so now if instead of absolute value of x, it's absolute value of, say, x minus 2 or x plus 7 or something like that, the procedure is pretty much the same. You just got to go a little bit further in the work, but for the most part, the setup is the same. Okay, so let me clear this. Okay, so here are some problems we want to look at. So I'll reach the following. Okay, these are the ones I just did. So I have the solutions written there, the same ones I just did, but maybe these are better to look at. The only thing is that here I would have a bracket or a shaded circle, and then this would be everything in between. And there's your different forms of the solution. This can be written this way or this way, and then the interval notation. Okay, so again, keep in mind if I'm going too fast here, just pause the video and rewind to look at the results again. Clear this. Okay, and there's the other one I did. Okay, and so the solution's written there to more clarity. And the other thing is that in this case, then I would have a bracket or a dot there, and I would take everything this way. Bracket here on the -7, everything that way. So you have your forms, your different forms. Okay, clear this. Okay, so now again, we want to solve this one. Now instead of just x, it's the absolute value of x minus 3. Okay. So again, I can't do the number line here because I don't have the x isolated yet. See, but all I would have to do is say, okay, let's, based on what we just did, the quantity in the absolute values has to fall between the 2 and the -2. Okay. Again, keep in mind I could write this as x minus 3 less than or equal to 2 and x minus 3 greater than or equal to -2, and solve the two inequalities separately, and then take the intersection, okay, because this is an implied intersection, and I get my solution. But it works out nicely if I just leave it in this form and just add 3 to all the way across here. Okay, keep in mind solving inequalities is pretty much the same thing as solving equations. I'm talking about inequalities that don't have absolute values, which is the case here. In this case, when you break it down like this. The only thing you have to remember is, just like equations, you can add the same thing to both sides, subtract the same thing to both sides, multiply both sides by the same number, divide both sides by the same number. The only thing is, when you multiply or divide by a negative, you have to change the direction of the inequality. So, example, if you have 2x less than 4, okay, I'm going to divide by 2 to isolate the x, divide both sides by 2. This would give me x less than 2. That's my solution. And I could say this is the one way to do it. I could write an interval notation, go from -infinity to 2. Same thing. Now the thing is, if you have something like -2x is less than 8, say, then to solve this, I would have to divide by a -2. Now here I have to reverse the direction of the inequality. So this would be x is greater than -4. And that would be my solution. And again, I could write this in interval notation also, okay? But let's get back to this one over here. Adding 3 all the way across here, I get x less than or equal to 5. And then this is greater than, adding 3 over here also, I get 1. Okay. This is actually one solution right here. And you can test it out by plugging numbers into the intervals, into the inequality here, and show that it satisfies it. Okay. The interval notation, because it has an equals, will go from 1 to 5. That's brackets. Okay. And the number line, This would be 1, 5. And I can either put a dot here and a dot here, or I can put a bracket. You'll see it in some textbooks this way. Brackets here, and then everything in between shaded. That's your solution. Okay. So different ways to represent the solution. Okay. This one right here could also be written x less than or equal to 5 and x greater than or equal to 1. Just another way to represent it. Clear this. Go to the next one. Okay. And keep in mind that, and the last one I just did, if it doesn't have the equals, it's just, you put the parentheses, okay, instead of the brackets. Never put brackets on infinity or negative infinity. Okay, on this one, based on what we did, because it's greater than or equal, absolute value greater than or equal to, this would tell me then that 2x plus 1 would have to be greater than or equal to 9. Or, okay, this is an implied union here with the greater than or equal to, or 2x plus 1 is less than or equal to negative 9. Okay, so then we go ahead and solve each inequality individually. So in this first one, I add a negative 1 to both sides. I get 2x greater than or equal to 8. Add a negative 1 to both sides. Divide by 2. I get x greater than or equal to 4. Or over here, 2x less than or equal to, adding a negative 1 to both sides, is negative 10 divided by 2. Okay, again, if you divide by a positive, you don't have to change the direction of the inequality. So in this case, this would just be x less than or equal to negative 5. So x greater than or equal to 4 or x less than or equal to negative 5 is one solution, one way to express the solution. In the number line, then I would have the negative 5 here, 4 over here. Okay, either shaded circle there or a bracket shaded this way. Same thing over here, bracket, everything this way. If it doesn't have the equals, the other thing is that you'd have an open little circle or there or parentheses. And of course, the greater than sign would not have an equals underneath over here. Okay, but this is just one way to express your solution right here. It's one way. There's your number line representation. And then the interval format would go from, okay, negative infinity is over here, so from negative infinity to negative 5. And then it's parentheses because it has the equals. And then it's or, so that's union. Brackets again. 4 to infinity. Okay, so that's your interval notation for your solution. Negative infinity to negative 5, union 4 to infinity. Okay, so these are your very basic absolute values inequality, absolute value inequalities, or inequalities involving one absolute value. Hope this helps you in your studies, and we'll see you in the next video. Take care.